Now, in addition to the ions we've already talked about, we also need to look at what we call polyatomic ions. Polyatomic ions are basically ions that are made up of a group of atoms that have a charge. And some of these are extremely common. Nitrate, phosphate is one you might be familiar with, especially if you're interested in biological processes. ATP, the P stands for phosphate. Carbonate, and chromate. We'll start with as our first group of four. Now, these are ones you're going to just have to memorize. Nitrate is NO3 minus, phosphate PO4 3 minus, carbonate CO3 2 minus, and chromate CrO4 2 minus. So with each of these polyatomics, and there's quite a few more after this page, basically three things you're going to have to remember. One is, what is the atom other than oxygen? Almost every one of these polyatomic ions that we're going to learn has an oxygen or some number of oxygens in it. We have to then know how many oxygens there are, what the charge is, and what the other element involved is. Now, the other element involved is usually the easiest one. So nitrate, nitrogen, we have that nitrogen right in the title. Same thing with phosphorus. Carbon for carbonate and chromium for chromate. But I have a friend of mine who came up with a set of mnemonics to try and help remember the other pieces, which is the number of oxygens and the charges. So he came up with a series of phrases that you can associate or not with each of these polyatomic names, and they may help you remember them. So for nitrate, for example, we're going to use the phrase low cost. Why? Well, you just have to ask yourself, why do chemists like nitrates so much? They're cheaper than day rates. So if we remember that, then we can think of the term low cost. For our phrase that we use, we then have to look at how many consonant sounds are in each word. The first word, the number of consonant sounds, is going to give us the charge. So there's one consonant sound in low, so that gives us the charge of -1. We don't really necessarily need to do anything to remember whether the charge is positive or negative. For these polyatomic ions, there's only one polyatomic ion that we're going to learn that's positive. So we can just assume that they're negative unless we're talking about ammonium. And then, so one consonant sound there. And then low cost, 1, 2, 3 consonant sounds tells us 3 oxygens. So now, if you remember that, nitrate, the first part of nitrate tells you there's a nitrogen. And then if you remember low cost, that'll give you -1 charge and 3 oxygens. Our next one is phosphate. And our association with phosphate might be that you might know that phosphates are used as fertilizers. So for phosphate, we could come up with the association crop farmer. Our first word, crop, has 1, 2, 3 consonant sounds. That gives us the charge of -3. And then farmer, 1, 2, 3, 4 consonant sounds for 4 oxygens. Carbonate might make you think of carbonation, or a fizzy tonic. Fizzy has 1, 2 consonant sounds. That gives you -2 charge. And tonic has 3 consonant sounds, which gives us 3 oxygens. Finally, among this group, chromate, maybe think of chrome as something being on a car. So we use the phrase car fitting. So car has 1, 2 consonant sounds for -2 charge, and fitting has 1, 2, 3, 4 consonant sounds for 4 oxygens. So before we go on to more of our polyatomics, just want to show how these would fit into our naming or our name to formula that we did before. So we could say, for example, that we had sodium carbonate. So sodium, we know based on where it is on the periodic table, +1. Carbonate, we just learned, CO3, 2-. In order for our overall charge to be neutral, we need 2 sodiums to equal +2 to combine with the -2 of carbonate. So our formula, Na2, CO3. Or we could do calcium nitrate. Calcium is +2. Nitrate is -1. So we need 2 nitrates. Now, if we just wrote it like that, to need 2 nitrates, that wouldn't get our point across very well. That would make it look like we have 32 oxygens. So what we do is we put parentheses around the entire nitrate group, and now we know that that 2 applies to the entire nitrate. So we have 1 calcium and 2 nitrates. All right, a couple more of these that we need to learn, and then we work on some variations. Permanganate, sulfate, and then we'll get into some other groups. Permanganate, MnO4-, and sulfate, SO4, 2-. For permanganate, we can think of an oil magnate. So oil, one consonant sound, -1. Magnate, 1, 2, 3, 4 consonant sounds, 4 oxygens. Now, sulfate, this one's a little bit different, but we might say that sulfate sounds kind of like sulfate. And we're going to go with sole, S-O-L-E, like the type of fish. So what is a sulfate? Well, in the case of this kind of sole, it might end up as a fish platter. Fish, one consonant sound, platter, 4 consonant sounds for the 4 oxygens. Now, you may have noticed that a number of these, these polyatomics end in ATE. Well, what about ITE? Well, if we have ITE, we lose 1 oxygen from ATE. So nitrite, phosphite, and sulfite. The charge won't change, just the number of oxygens. So for example, nitrate was NO3 minus, so nitrite NO2 minus. Phosphate PO4 3 minus, phosphite PO3 3 minus. And sulfate was SO4 2 minus, so sulfite SO3 2 minus. We also have a set of variations where we add hydrogen. And more specifically, we're adding H plus. So for example, we had sulfate, SO4 2 minus. We added a hydrogen, becomes hydrogen sulfate. And because we're adding something that's positively charged, our -2 becomes -1. We can do this with a number of these. Carbonate, for example, CO3 2 minus. We add an H plus. It becomes -1. And we now have hydrogen carbonate, which you might also be familiar with because it's also known by the name bicarbonate. Bicarbonate being, the ion in, or the anion in sodium bicarbonate or baking soda. Or with phosphate, phosphate is PO4 3 minus. We can add 1 hydrogen, get HPO4 2 minus. This would be hydrogen phosphate. We can even add a second hydrogen, H2PO4 minus. Dihydrogen phosphate. And finally, for our list of polyatomics, a couple others that we just kind of need to remember. So we have XO3 minus. Whenever we use this X in a formula, it usually means that we're dealing with a halogen. And in fact, the phrase we can use here is any halogen. Any, one consonant sound, minus one, three consonant sounds, three oxygens. And so this could be ClO3, chlorate, BrO3 is bromate, and IO3, iodate. And just like we saw with our other polyatomics, we could also have ITEs. So ClO2 minus is chlorite. Bromite, BrO2 minus, and iodite, IO2 minus. Finally, just two other ions that they don't have any phrases or mnemonics to help you with. These are just ones we have to, just going to have to learn these. We have C2H3O2 minus. This is known as acetate. Acetate is actually very closely related to acetic acid. If you're not familiar with acetic acid is what you smell when you open a bottle of vinegar. But acetate is just acetic acid that's lost a hydrogen. We'll talk more about things like that when we learn about acids and bases. And then NH4 plus. This is our one and only polyatomic that we're going to learn that is positively charged and has the name ammonium. All right, last thing we do in this chapter, this section, is to talk briefly about what we call molecular compounds. These are non-ionic compounds. Formed from two nonmetals. And we will come back and revisit these near the end of this course in much greater depth. But for right now, we're just going to talk about these very, very briefly. There's some commonality with naming of these and what we learned for ionic compounds. We said with ionic compounds, we name the first element, and then we put IDE for the second element. Molecular compounds are a little bit more complicated. And just to show you some examples, and these are just a relatively simple group. If we had carbon and hydrogen, we could have CH4. If we had two carbons, we could have C2H2, C2H4, C2H6. At three carbons, we could have C3H4, C3H6, C3H8. And as this number of carbons increases, the number of different possibilities for the number of hydrogens increases. So it's no longer enough for us to just list the first element, and then IDE the second element, because if we did that and said carbon hydride, which one of these are we talking about? So for naming these molecular compounds or two nonmetal compounds, we need to include numerical prefixes. So what we do is we name the first element. If there is more than one, then we add in a prefix. For the first element, if there's only one, we don't need a numerical prefix. Then we, as we have with the other compounds, we IDE the second compound, or the second element. Always add prefix. All right, what are these prefixes? Some of these you probably know, most likely from, say, a math class. Some of them are a little harder. One is mono. Two is di. Three is tri. Four, and this is the one that trips students up more than any other. Four is tetra. Above four, they're usually easier because if you think of your polygon shapes that you would have learned in a math class, you probably know these. So five is penta. Six is hexa. Hepta. Octa. Nona. And deca. So we'll just show a couple of examples of how we would do this. So the compound NO, the first element is nitrogen. Now because it's the first element, there's only one of them, we don't need a prefix. The second element is oxygen. Because it's the second element, oxygen turns into oxide, but we also need a prefix to say how many of them there are. So nitrogen monoxide. How about S2O3? So in this case, both elements have more than one, so we will need prefixes for both. So it's sulfur, there's two. So disulfur, and then there's three oxygens. So we add the IDE ending, and so it becomes trioxide. B2F6, there's two of the boron, so we say diboron, and then six fluorines, hexafluoride.